Hello friend, my name is Nitish Chandraja, currently pursuing my masters from IIT Patna in the department of VLSI and embedded system. So here my objective is to design a low pass filter where LED is used for sound filtering status and push pull button is used to start and stop the filtering process, and input is taken on the ADC using function generator where timer is used to achieve exact sampling frequency of 256 hertz, and the cutoff frequency is 29 hertz. So basically what I do, what is first order filter? So as we know, the first order filter which is allowed to use a low frequency signal to pass through while reducing the amplitude of high frequency signals. So here is a transfer function which is omega naught upon s plus omega naught. So this formula basically describes how the filter modifies the input signal, and in the discrete time domain this function can be written as y of n is equal to alpha into x of n plus 1 minus alpha into n minus 1, where x of n is the current input, y of n minus 1 is the output from the previous sample. Then I'm going to find the formula for precision, which is alpha. So alpha is a parameter which determines the influence of the current input and the previous output of the filter behavior. So basically alpha is equal to 2 pi fc upon fs plus 2 pi fc, where fc is the cutoff frequency and fs is the sampling frequency. So basically what I am taking here I take my cutoff frequency as 29 hertz and my sampling frequency as 256 hertz. So when we calculate alpha, then our alpha comes out to be 0.4156. Then I again find the 1 minus alpha, which comes out to be 0.584, and now we put this in these values in my equation which is in the discrete time domain, basically described here. Y of n is equal to alpha into x of n plus 1 minus alpha into y of n minus 1. So basically I put my values here, and this is the block diagram. So basically this block diagram illustrates the discrete function or discrete form of the filter, showing how the current input x of n is weighted by alpha, and how the previous output y of n minus 1 is feedback into the system weighted by 1 minus alpha. So and here what is do? So here our objective is to create a low pass filter which include an LED indicator for the filter status and push button to start or stop the filtering process. The input signal is sourced from an ADC, and the implementation utilizes a timer to ensure a precise sampling frequency of 250 hertz with a cutoff frequency of 29 hertz. So here is the implementation details. So basically where we take ft is equal to f system upon arr plus 1 plus into prescaler plus 1, where arr is the auto deload register and the value auto deload register value, and f system is the system frequency. So then I am going to calculate my prescaler. So basically prescaler is defined as f of system upon ft into arr plus 1, so in minus arr plus 1 whole minus 1. So when we calculate my prescaler value, it comes out to be 4, and this is the graph that depicts the frequency response of a low pass filter, indicating the cutoff frequency in radian per second, and it also shows how the signal magnitude diminishes as frequency increases, which is a key characteristics of a low pass filter. Here is the code which I had written for the program. So basically include main.h, which is a header file which typically contains functions, prototype and configuration. Then I define my sampling frequencies, which is set to 256 hertz. It means that my data is sampled to 256 times per second. Then my cutoff frequencies, I set it to 29 hertz. This is basically the cutoff frequency for a low pass filter. Then ADC handle def HADC1 and TIM handle type definition. Basically HADC1 and HTIM1 are handles for the ADC and the timer peripherals which is used to interact with hardware. Then I write a program for float alpha and basically alpha, which is a low pass filter coefficient, that will be calculated based on the cutoff and sampling frequencies. Then here is my previous output, which is basically stores the output of the low pass filter to apply a recursive filter term. Then ADC value 1 which stores the raw value which is read from the ADC. Then filter active, it is a flag indicated whether the filtering process is active. If it is active, then 1, if it is not active, then 0. Then my filtered signal which stores the filtered signal output. Then it is a void system clock configuration. These are the prototype for system configuration, peripherals, initializations and the utility functions. Then I calculate alpha. Basically calculate the alpha low pass filter coefficient alpha using the RC time constant and the sampling frequency. Then float apply low pass filter float input. Basically it applies the first order low pass filter to input using the recursive equation. The result in stored in previous output and then it returned. Then I have defined a handler function. So enters in infinite loop. If there is an error coming, then it will enter into infinite loop, and it can be used to indicate error via LED or other outputs. Then here is my main program. So basically these are my main program. First I initialize my hardware abstraction layer HAL. Basically first I initialize my hardware abstraction layer HAL and system clock and sets GPIO, ADC and timer peripherals. Then calculate alpha which is basically the low pass filter coefficient. Then the ADC is started and the timer interrupt is enabled. Okay, then after I define a while loop and write our program here. So basically this is the main loop which checks if a button connected to GPIO pin, if pin PA0 is pressed to toggle the filter active flag which control whether the filter is applied. If the filter is active, an LED on GPIO PA5, if LED is active, then GPIO pin PA5 is turned on, otherwise this pin will be turned off. Okay, then timer interrupt and callback. So basically this is for timer interrupt and callback. This callback is triggered when the timer generates an interrupt at 256 Hz. If filter active is true, it reads the ADC values, applies the low pass filter and stores the result in filtered signal. Then system clock configuration basically configures the system clock using an internal high speed oscillator and phase lock loop. Then after GPIO initialization I will do here. Static void here the GPIO initialization configure a GPIO pin PA5 as an output which is used for LED control and PA0 as an input which is used for the input for the button, which is basically used for input button. Then ADC initialization, here I initialize my ADC initialization. I initialize the ADC1 peripherals with a clock, a prescaler and 12-bit resolution. Then after timer resolution, then after I will go for timer resolution configures as timer 1 to generate interrupt at 256 Hz by setting the prescaler and period value, which is done. And when I build my project, then it gave me build finished and 0 error, 0 warning, and basically time took.